In the previous video, we looked at what are the different types of data and who actually produces that. So in this video, we will now focus on what would be the kind of formats that you're likely to encounter in the real world. So let's start with understanding the basic difference between structured and unstructured data. Now, most of the literature that you see online or in other courses ends up confusingly using these words loosely, and that's because there is no standard definition that actually has been agreed to, and these are not formal terms by any stretch of the imagination. For want of practicality, let's maybe use one standard set of definitions that we will use for this course, and I'll propose that in the next couple of slides. And this can be a useful way to think about how data gets generated and stored in the real world, and we can map it back to this way of understanding the formats. So fundamentally, a structured data, as the name suggests, has some structure to how the data is formatted. Now, it's not necessary that the structure has to be in a certain template, or it has to fit in a certain tool like Microsoft Excel or a relational database. None of that is necessary. All that structure really refers to is the fact that the data has some structure, and that structure is known in advance or is describable in advance, and therefore anybody who looks at that data, who understands that structure, can know to interpret that format. And in particular, what's of interest to us is the fact that machines who know that structure, who have been told that structure, can use that structure and use that information to get to the data that's being formatted in that particular manner. That distinguishes it from unstructured data. In the world of unstructured data, the data is not structured in a certain form, and therefore it's much harder for a machine or a piece of software to take a look at it and make sense of it. At least that's how the definitions were initially thought about between structured and unstructured. The example of an unstructured dataset would be something that is free-form text, like spoken language, written language as an example, or binary datasets like videos and images and audio clips, right? Whereas the world of structured, like I said, has some structure. So the structure could be something that's very easily understood, rows and columns of data, like CSV. CSV refers to comma separated values. XML is another standard which has been around for 30 years, more than that, and that is a different form of data, JSON, etc., etc. So we'll take a look at some examples. So the first example I'll give you is this CSV data. So a CSV refers to the fact that the values of the data set here are separated by a comma, right? Comma separated values. That's what CSV stands for. What are the values that we're talking about? In this case, this looks like a month, followed by a hyphen, followed by the year in the YYYY format, and the value here in the second column is some kind of a number. Usefully, the CSV also has the definition of what these columns are, at least the column names, right? Available as row number 1 in that particular batch file. And as we guessed, right, the first column refers to month, and the second column refers to some quantity called as ACR. In brackets, we see that it's US dollar, so it looks like some kind of a monetary number. So that's basically the kind of inference that we can draw by looking at a CSV file like this. So two columns separated by comma, and each row of data corresponds to a separate data record, which means individual data records are separated by a new line character, right? That's why it's wrapping around to the new line. All right, so what is an XML structure? So in the XML structure, you get more elaborate descriptions of what the data is. So here's an example from, interestingly, a configuration file right? Ultimately, config file is also storing data of some sort, right? So this config file is commonly present in Hadoop clusters. So you'll see this all the time. Now the config files themselves are XML based. So let me help you parse this. So at the start of it, you see there are angular brackets surrounding the word property, and there are angular brackets surrounding the word slash property. So in the world of XML, this kind of a syntax denotes that there is the property element that is getting described between these two sets of angular bracket keywords, right? So the start of the element is usually denoted by the name of the element, and the close of the element, right? So the extent to which you need to read before you know that you have the full element data is usually denoted by the same name of the element but preceded by a forward slash. Okay, so this property element itself comprises of two different elements. One is the name element, which has name as the keyword that starts and slash name as the keyword that stops that value, and there is the value element. So there is no special meaning attached to the word value here, except that it's just an element, and likewise the name as well. Now, what does the name element comprise of? In this case, it comprises of a text. The text is itself some kind of a free-form string, and it so happens that here the free-form string has a specific format, right? That's called yarn.scheduler.minimum-allocation-mb. And then the value element has some number, here it's 32. So a human who looks at this kind of can infer that, you know, the value that's mentioned here, 32, is actually the value of this property name. And the property name is yarn.scheduler.minimum-allocation-mb. And in fact, you can even deduce that 32 is a number whose units are very likely to be megabytes, right? That's what MB refers to in this particular context. Likewise, the same config file, the same data file written in XML has other property elements. And here, the second property element has again a name element. The name element has the value yarn.timeline-service.enabled, and the value element here has the value true. So notice that the name element has a similar structure or a format to the name element of the previous property, which means it's just a bunch of characters with some special characters included like hyphen and dot. But the value element here is not a number, right? It's actually an ASCII set of it's textual characters. Here it's a number, and here enabled or disabled, a human looking at it can infer this is some kind of a Boolean variable. So instead of representing Boolean as 0 or 1, it just represents it as true with characters TRUE, right? So notice that in the world of CSV, each record looks exactly the same. In the world of XML, each record need not look the same, right? In fact, it can have multiple levels of records within, and each of those records themselves can be nested, can be having different values of different types. So that's the advantage with XML style formatting, because it allows you to pack data of different types, data of heterogeneous variety into just one data file, into one batch file. And exactly the same for JSON, JavaScript object notation. Here, unlike XML, which has very detailed structure representations like the angular braces, the start of the element and the close of the element, etc. In the world of JSON, it's all mapped and available as a dictionary of key value pairs. So the key occurs to the left of the colon and the value occurs to the right of the colon. And by having multiple such key value pairs and enclosing all of that in curly braces, it constitutes one data record. So a typical JSON file has multiple such data records, multiple such angular close brackets, or rather curly braces open and close. And then the specific set of key value pairs which are possible within a pair of open close curly braces can be variable in number. It need not be the same. So like XML, you could have multiple different data records in the JSON file having completely different types of key value pairs, and that's perfectly reasonable. Unlike CSV, you could have flexibility in the nature of the data. Excuse me. So here the key value pairs themselves are free form, right? So here I've used T_policy number as a key. Another example is file name, _name, etc., etc. The value can be characters, can be special characters, can be embeddings, can be values, can be itself like a free form text, like in this case, like from colon to colon, etc. So again, maximum flexibility. Alright, free text. How does that look? This is actually quite common, right? We've seen this all the time when we use these food aggregator apps, when we use Amazon or Flipkart to go buy books. We can go quickly read reviews. And if you see really what is the format in which those reviews are present, there is some kind of a structure at the top level, which is basically give me a subject line, give me like a star rating, the time of the day when the particular rating was given, who gave the rating, etc. It's all about the structure. But the unstructured part is really in the free form text. So in this case, so the text comprises of like a bunch of characters separated by paragraphs and controls and so on. None of that is actually made mandatory, right, by any form or any software. You can just enter free form whatever you want. You could enter in English or Tamil or Telugu, and it doesn't really matter. So that's why this is called as unstructured, because there is no specific structure to how this data is present. Sometimes it could be a bad review. In fact, you could come and write completely irrelevant reviews as well, right, or comments on Amazon, and nobody really gets to know about it unless a human takes a look at it and says, okay, this looks like spam, they're advertising something else. It's not really connected to a review of the use of the product. And finally, binary, right? An image like this, in this case it's my selfie, is in reality stored as a bunch of bytes. And those bytes are having very little structure. So in this case, the image could be a JPEG, in which case the bytes are laid out as per the JPEG protocol. But you could also layer it using some other image protocol, right? Like for instance, GIF, or it could be BMP or something like that. Or in the most general sense, it's just a bunch of bytes. And therefore, there is very little structure to how to interpret those bytes unless you're told separately that there is a protocol that it's following, like JPEG and things like that. By the way, in general, if you're given a binary data type and you're not told what is the encoding of the data in that binary data type, it becomes in general very hard to reverse engineer from there to get the data that's being stored within it. So keep that in mind. Let's delve deeper into the CSV format. Now, this is actually one of the most common ways in which data gets exchanged, especially when you're dealing with legacy systems. So it's important to understand this. While modern internet software has moved towards APIs, and APIs in turn have used either XML or JSON, CSV is still so popular. It's so popular that it's actually been the base of all data exchange, and it's also been the base of all data engineering problems. And really the problems come from not having a standard specification of CSV. There has been actually a lot of effort towards standardizing the format in which CSV files can be created. One of the oldest ones is what's called as RFC 4180. RFC stands for request for comments, and again, it's one of those vestigial remains of how standards used to be created for protocols back in the day, right? IETF is the standardization body. Internet Engineering Task Force is what it's called, IETF. And IETF used to follow this process of creating standards where they would propose a bunch of things that need to be, part of the standard, and then they would open it up for comments. That's why it's called request for comments, RFC. And then once the request for comments is open for a duration of time, and people can add their comments and suggestions and so on, that then this committee which is responsible for that particular RFC which is floated out, and in this case, if you take a look at the 4180 protocol standard for CSV, there would be that committee for 4180 which would take in all those comments and pass them and decide what to do with it, and then finally freeze in the standard. Once the standard is frozen, the RFC terminology will still remain, and that's how you get the RFC 4180 CSV standard. Okay, so the CSV standard is actually a simple format for representing what is formally called as the rectangular array of numeric and textual values. So it is an example of a flat file format. The flatness refers to the fact that there is no nested structures. There is no data within data, right? All data is at the same level, and all data is homogeneous. It adheres to a certain, metadata. Metadata refers to what column, what value you're expecting for each of those columns, and whatever value you're expecting for the first row for that particular column is exactly what you can expect for the last row for that same column. That's why it's useful to think about it as a matrix, because the moment you define a matrix, it's rigid, right? All the cells for the specific column remain the same, so it becomes something that's homogeneous. It's rectangular because you can't have variable widths, meaning some data records cannot magically have more columns than some other data columns, right? Some other data records, all of them have exactly the same number of columns. So that's what makes it rectangular. So in other words, you could take a CSV dataset, put it into an Excel sheet, and layer a spreadsheet table on top of it. It will fit perfectly, right? So that's how you can visualize this. Great. So what makes it a CSV? Now the C refers to comma, like we spoke about in the previous slide, but that's really a misnomer. What the standard really said is, comma or not, that's all right, right? It doesn't really matter. What matters is there is a delimiter which separates multiple columns, right? One column from another, it separates with a delimiter. That delimiter happens to be by default the comma in the RFC standard. So when somebody says, I'm giving you a CSV, it's likely that they put comma as the delimiter, and that's why they've used the word CSV. But somebody who's adhering to the RFC 4180 standard could have used a different delimiter, like tab character or dollar character, caret character, etc. Right? As long as there's a delimiter and you use it correctly for all columns or all rows, that's fine. And the second aspect of the specification says that multiple data rows or data records are separated by characters indicating a line break. A line break is visually represented as though it's a new line, right? Or in terms of ASCII, line break is actually one character, one specific character with a special symbol. Alright, so the RFC 4180 says that to denote line breaks, you'll have to use a carriage return line feed pairs. The carriage return itself is a special character. You can see its definition here, and the line feed is also mentioned here. Now, don't be too worried about what CRLF means, etc. In real world, when you see a CSV file, you see this new line beginning for every new data record. That's what we mean by like line breaks, basically. So, yeah, we spoke about the fact that each data record contains exactly the same number of fields. The fields that contain a special character. What constitutes a special character is one of the characters used to, define the format of the file, right? Like, so if you use comma as a delimiter, and one of the fields has a value which has comma in it, then any machine that's trying to read the file will get stuck in that particular row because it's expecting to find a comma as the delimiter between multiple fields, but it's now found a comma for a value that's actually occurring in a field. So therefore, it will try to split on that comma and treat either part of that value as belonging to two different fields. So as a result, what happens is the entire set of fields gets offset by 1. So as an example, if I were to go back to this example here of a CSV, so here the values are all clean. So I've got the month, comma, the US dollar number. For some reason, let's say one of the entries here says 124,0506. That could be a genuine typo, right? I'm not expecting a comma in a number field, but it could also be possible because US dollar money, therefore, the place of decimal is denoted using commas, so hundreds, thousands, and so on. So therefore, somebody manually entered a comma. Could be the case, right? In which case, the comma here, if it occurs, will get treated by a machine that's reading this as though the value of the second field, which is ACR US dollar, is 124, and there is a third field which is occurring after this comma, which is 0506. And that would throw an error because I'm not expecting a third field, right? The rest of the data records just have two fields. So that kind of a problem comes because the field value itself contains the special character, in this case the delimiter character. The example that I just gave for delimiter occurring in the field value is also possible if the line break characters occur as part of a field value. Right? Somebody is typing in free form text like this, they press enter, the enter translates into a line break, and then when that gets stored as a CSV, then that field which denotes that entire free form text could actually have a line break character. And if that occurs, then anything occurring after the line break is treated as though belonging to the next data record, which would be wrong, right? Because if I feed this comment as an example, the line break has occurred here, the next data record is actually another line break because there's an empty line. And that empty line has just no fields, no data, which means when the machine is trying to read and it's trying to look for a comma because it's looking for two fields, there is no comma, it's an empty line. So it will throw an error saying that unable to parse and find a delimiter. So fields that contain these kinds of special characters must be escaped by enclosing them in double quotes. So if I take this example, in the JSON example, the value and the key are both encapsulated within double quotes. Likewise, if you're anticipating a special character like the comma in this number field, you put this entire thing in double quotes, right? So the entire field will be in double quotes. That way, whatever special characters occur within the double quotes are escaped, meaning the parser which is parsing that data, the machine that's parsing the data, knows that I should not pay attention to the special characters that occur within it, because everything within the double quotes is considered part of that same field. In other words, in real world, if you encounter a CSV file which is badly formatted, right, you would most likely see examples like this. The delimiter character occurs inside the field. The special characters occur inside the field. One of the fields has new line characters because somebody's entered the data with pressing enter, etc., etc. In those kinds of situations, you end up having to think about, oh, how do I clean this? Do I put how do I escape this? Because escaping a field for all fields, for all data records, is not a trivial activity. You'll have to go write code for it, right? The other way to solve for it is, if you analyze your data and you find that those occurrences of the delimiter, as an example, are only going to be in certain fields, and therefore, can I choose a different delimiter? A delimiter which is not occurring in any field, like a dollar, like a caret, like an asterisk, like a ampersand, like many different ASCII characters are possible. As long as it's a single character, you can use it as a delimiter and choose a delimiter that's not occurring in your data set. That way, you can still adhere to the CSV standard. You can call it CSV, you can call it something else, doesn't matter. or you can call it a .dat file or .flat file, right? But then when the parser looks to read it, like a machine is trying to read the data, you declare that the derivative is actually a special character that you define for yourself. So what happens if a field is a string field and it has double quotes also, right? Which means if I try to escape with double quotes and there are double quotes within the field, then again the machine that's trying to parse it could be mistakenly led to believe that the escape sequence is over, which is not right, because the double quotes is occurring in the middle of the field. In that kind of a situation, there are two ways to deal with it. You can either escape the double quotes by putting in a backslash, basically, just before the double quotes, or even better, choose a custom double quote character, meaning choose a custom escape character which is meant to encapsulate the entire field. Don't use double quotes, use single quotes as an example, right? Or use dollar, use caret, etc., etc. So the format is fungible, right? It's actually quite flexible, but if you choose the special characters wisely, you can really create clean data. Okay, so many CSV files have optionally a header meaning the first line denotes what can you expect as fields within. So again, take a look at this example. The first line gave me the name of the column, right? So this is month, this is ACR, and this is applicable for all the values of all the data records for that particular field. Excuse me. And then finally, the entire CSV format commonly employs ASCII character set, and especially so for the special characters, you have to use ASCII for it. But then you could also use other character sets for the field values, not a problem, right? You could use Unicode for being able to store Hindi text as part of the CSV. That's perfectly fine, not a problem. Just be aware of special characters, because the moment you get into Unicode, some Unicode characters, when you break them down byte by byte, the byte which is part of a bigger Unicode character could standalone be interpreted or parsed as though it's a special character. So in those kinds of situations, you'll have to be a bit careful. Occurs especially with non-English Unicode encodings. Alright, so I'll stop here at this stage. In the next video, we'll look deeper into the other formats of data and how to process them. Thank you.